Hi, everyone. Thanks for tuning into this week's Stacker Chat. My name is Gina Abrams. I'm an early team member with the Stacks project, and I'm joined by Stacks co-founder Muneeb Ali. Thanks for being here, Muneeb.
Awesome to be here.
Excellent. So for anyone that's new here, the Stacks 2.0 blockchain launched earlier this year, bringing apps and smart contracts to Bitcoin. Today, we're going to cover some of the design decisions that have come about in building Stacks and some of the methods and places where maybe we've zigged where other folks have zagged. So one of the things that comes up in a lot of conversations is about different design trade-offs for developers when evaluating different layer ones to build on. Now, Stacks is a layer one that's connected to Bitcoin, settles on Bitcoin, has unique insights to the Bitcoin blockchain, and can essentially program around it. And right now, Stacks blocks are in tandem with Bitcoin blocks, which introduces a level of scalability. However, there's been a lot of talk about microblocks and making these transactions and sort of insights even faster. So I'd love to hear a little bit more about microblocks to begin with, and then also sort of your perspective when it comes to scalability versus decentralization and what you're seeing as important on the horizon.
Yeah, I think these type of design decisions are, I would say, pretty fundamental to any distributed system, like decentralized systems like blockchains. And the one way to think about this is that a lot of people, they think of scalability as some sort of a technical breakthrough that, someone came out with a technical breakthrough and now we have a more scalable blockchain. Whereas I think the right way to think about scalability in the context of blockchains is it's a trade-off. So when you're trying to make something go faster, you're actually giving up on something. And it's extremely important to understand what is that thing that you're giving up on, and do you feel comfortable giving up on that thing, right? So I can actually give some examples. One of the most kind of like unique things about Bitcoin and the Nakamoto consensus was open membership, right? So it's a consensus protocol, but it's an open membership protocol, meaning that anyone can come in and become a Bitcoin miner. It's open, it's decentralized, and you're not restricted to just a kind of like group of nodes that are closed, right? Because that starts looking like a federated system or a permission system. And there are some, and those algorithms have been around for a very, very long time, right? So if you look at more traditional, Paxos or newer versions of Paxos-like algorithms like Raft, these algorithms have been around for a while, but they're not open membership algorithms. So if you look at a system like Definity, for example, they are talking about extremely fast kind of like transactions or very high scalability. And it's almost like it boggles a normal kind of like, crypto user's mind a little bit that, hey, what breakthroughs have they had because of which they're able to kind of like, give that type of scalability and block times and so on. And interestingly, if you look at the system design, it's not an open membership system, right? So if it's not an open membership system, like these types of algorithms have actually been around for a very long time. I'm not trying to criticize the project or anything. Like it's a design trade-off, and I think they've made a certain design trade-off to optimize for certain metrics. And the kind of like the flip side of the same trade-off is that you're giving up on something. And I think one thing that we have done at Stacks is that we are pretty much in line with the design principles of Bitcoin, because we truly believe in that. Like a lot of our team members are early Bitcoiners, and we, as computer scientists, we are pretty much in the camp that decentralization and the permissionless nature is the most important thing here, right? Otherwise, you can't. And let me double down on that a little bit. Especially for the base layer protocol, decentralization is the most important thing, because you could always make more restricted things on top of it, but you cannot start off with a closed membership system and then try to create something that is more decentralized on top of it. That just doesn't work, right? So you can always restrict on top, but the base layer has to be fully decentralized. The base layer has to be independently verifiable, right? So anyone can go and do that. So linking back to scalability, a lot of times people would think about scalability not as a trade-off with decentralization. And I think that's a critical connection to make, that if you're trying to say, hey, we want to have more transactions per second, which it's a separate topic, that it's a little bit of a meaningless metric. But what are you giving up for that, right? So for Bitcoin, it is actually kind of like very important that people with a normal internet connection and a normal computer should be able to directly connect to the network, should be able to have an independent copy of the blockchain, and should be able to independently verify that this is the correct version of the blockchain. A lot of kind of like the designs where you start kind of like increasing the requirements on what type of a computer you would need to connect to this network, or what type of bandwidth kind of like links you would need to connect to this network, change the decentralization properties of the network, because now not anyone can participate, but you're actually restricting it to maybe really high powered computers or people with data center like connectivity, that only those nodes can participate. And that's a design point like worth exploring. But in my view, that's not how the base layer protocols should be designed, because you could always kind of like create other systems on top of a very decentralized base layer that can give you those properties, and people can opt into them as possible. So Stacks kind of like takes that approach where we want anyone who wants to run a Stacks node to effectively have the same type of a hardware or a internet bandwidth connection that a Bitcoin full node would have. So we are trying to be on the end of decentralization. And then how that shows up is that like Stacks blockchain, at least at the base layer, is not optimizing for very, very high transactions per second. But with that said, I think it is a good user experience if you can get faster initial confirmations instead of waiting on Bitcoin blocks. So the way the Stacks blockchain is designed is there's a concept of micro blocks, right? So if you imagine like almost like visualize two blockchains where Stacks kind of like connects to Bitcoin and does settlements on Bitcoin. So we follow Bitcoin's finality, which is a probabilistic finality anyway, but Stacks kind of like follows the finality of Bitcoin. But on the Stacks sides, you can actually have much faster initial confirmations, and that those initial confirmations would give some information to the users that is useful, and they can kind of like use that as they see appropriate. But finality would be driven by Bitcoin, right? So the normal Stacks blocks have a direct relationship with Bitcoin blocks. Every Stacks block has a corresponding Bitcoin block, but micro blocks can effectively have more transactions. It's almost like streaming, right? So people are streaming transactions, and let's say they're every 30 seconds instead of like every 10 minutes, there's a new micro block. And then there is another micro block and another micro block. And all of those micro blocks can be packaged up into the same kind of like full block that then settles on Bitcoin and gets finality from there. But things actually become even more interesting because these micro blocks are viewable in the mempool. So if somebody is watching even kind of like the Bitcoin mempool, where Stacks miners are broadcasting kind of like, that's where the competition is happening from the Stacks miners to win the blocks. You could actually just look at the state of the mempool to know that, let's say, every miner that is trying to mine a block has my transaction, right? So it doesn't matter which miner actually ends up winning the block, your transaction is actually getting it. And there are very interesting incentives baked in as well, where the Stacks miners are incentivized to include as many micro blocks as possible in their blocks. So effectively what that does is that you get a very fast confirmation as a microblock. And then based on the state of the mempool, your probability that this transaction is actually getting in could be extremely high. It could be close to 100% if all miners are cooperating and they're including the your transaction in a microblock, which is a very interesting and nice property to have, because now the UX for users could be very fast transactions. And right now it's around 30 seconds, but there could be future improvements to make it even faster and so on. So I think I'm very excited about the release of microblocks. The bulk of the work is actually done, but it's more of the UX side, like the wallets or exchanges or the Explorer, where it has not been fully integrated. And obviously, it will be great to kind of like see a proper launch of the microblocks where a lot of the community members and users can actually get access to it. I'm personally pretty excited about that launch.
Excellent. Yeah, can't wait for that. Cool. So you mentioned, you touched on this a little bit, but it's been said that transactions per second could be considered more of a vanity metric when it comes to blockchains. I'm curious to hear a little bit more about some of the metrics that you really value and that you're looking out for in terms of these robust layer ones of the internet.
Right. So I think the way I think about this is at the base layer, the metrics that are important to me are decentralization. And it's sometimes becomes hard to quantify, like, what do you mean by decentralization? But there are certain ways you can actually even quantify what decentralization means. Balaji actually had a great talk at one of our summits back in 2017, I believe, where he was trying to quantify decentralization. And I think it's easy for people to understand that, for example, Bitcoin would score very high on the metric of decentralization. And I think that matters to me personally in terms of the designs of the base layer. And another thing is independent verification. Like, can anyone boot up a node and without talking to any trusted source or third party, can you independently verify the state of the blockchain, and how quickly can you do that? Right. So it's somewhat tied to decentralization, but it's a slightly different property that I think is extremely important when you're talking about base layers. And when you're talking about transactions per second, the way, I think it has become a little bit of a, every project has their own metric for transactions per second. And we have lost the meaning of, like, what does that really mean for your applications? I think for smart contracts that run on the base layer, it is still more meaningful to talk about how many transactions you can have, because you're trying to interact with these smart contracts. And I think over there, it still makes more sense. But broadly speaking, we're talking about an entire internet that is powered by blockchains, or you're talking about decentralized applications. Most of the state for these applications is actually not going to live on chain, right? So if you're talking about something like Facebook that does 5 billion likes a day, or maybe even more than that, there's no world that I imagine where every single like actually triggers some sort of a blockchain transaction in a future version of a decentralized social network, right? So in terms of like interactions per second, or how users are kind of like muting user data, most of these things are going to scale not at the base layer, right? They're going to scale in some other way. And if they're going to scale in some other way, then why are we obsessing so much about transactions per second at the base layer directly?
Absolutely. Now, changing topics a little bit, you recently shared a tweet about the BurgerSwap exploits, where $7.2 million of value was drained from BurgerSwap on Binance Smart Chain due to a reentrancy bug inherited from Solidity. In contrast, the Stacks ecosystem offers clarity for building out secure, decidable smart contracts. Can you share more details on sort of the different approaches here and what folks might expect from clarity that's different from Solidity?
Yeah, so I think this is a really fundamental debate, and people would take either side of that debate. The debate is basically that Solidity is a Turing complete language, which is both a powerful thing but also a double-edged sword, and you can hurt yourself. And I think there's enough evidence now of people over and over again hurting themselves. Like, these are developers. Sometimes, these are the mistakes are actually errors. Sometimes you could even argue that, people are actually being malicious, and they would have done something malicious anyway. And it's just like they were using a design flaw in a language to do that. But the debate is effectively that because Solidity is a Turing complete language, anything is possible. And reentrancy, for example, is allowed. Somebody would exploit that, and people would just need to learn to be careful and get more audits and so on, right? So if you think about like the design space of languages, like Turing complete languages would be kind of like the superset of everything, right? Like, and then like if your language is Turing complete, you can pretty much do anything with that thing. So if you try to restrict that a little bit, let's say you make the set a little bit smaller, and then that set is as decidable languages, where you're not as expressive as a Turing complete language. You have explicitly restricted yourself, but you're gaining a lot of benefits. Like, these things are more, these programs are now more predictable. You can actually do analysis on them before running these things, and so on. And one of the things with Clarity, other than kind of like, Clarity being explicitly being a decidable language, one thing that the original designers thought a lot about is, we should not allow reentrancy, period, right? So reentrancy is actually not possible in Clarity contracts, which is a feature, right? And some people might argue that, hey, it's not a feature, it's a limitation. Like, maybe I want to write some application where I want to use reentrancy as a feature. And I think my question to them would be like, why don't you come up with what application you're trying to build, and then really try to think about, is it really not possible in Clarity? Because most of the time, these applications can be written in a way where you can get the same functionality without relying on things like reentrancy, right? So by almost like restricting yourself and banning a certain type of a feature from the programming language itself, in my view, you're actually doing a lot of benefit to the developers who might not be that knowledgeable about these potential pitfalls, right? So you're in some ways giving them more precise tools with which it's harder to hurt themselves, right? And I think that's actually a very, very nice property to have, because smart contracts are a very different type of computer code. These things can have millions of dollars of assets on them. And I think optimizing for predictability, optimizing for kind of like security needs to be kind of like the number one thing. And instead of basically saying that, okay, over time and with enough errors and with enough audits, people would learn how to write more secure smart contracts. I feel like that's kind of like not the approach that needs to be taken here.
Absolutely. Thank you. Now, you're not going to Bitcoin Miami this year, although we will have some folks from the Stacks ecosystem there. But maybe you're having a little FOMO. I'm just curious to hear a little bit more about any sort of quick crypto crazy stories from events in the past, or anything that you're looking forward to as the world opens back up.
Yeah, I think I'm definitely going to miss a lot of friendly faces and colleagues I'm getting so many messages. Everyone's like, people are actually assuming that I'll be there, and they're trying to meet up. They're trying to kind of like set up gatherings with friends, especially like, people are coming out of COVID. And I think I'm always a little bit kind of like more paranoid and more careful generally in life. And plus, I have some other family commitments going on, due to which I won't be able to be there. Well, I will miss everybody. Hopefully, I can see them soon. And I feel like there's always like one or two events in the year that are kind of like the epicenter of the crypto industry. Everyone's excited about them. Everyone shows up there. Back in the days, like Consensus used to be that in New York. I've also experienced some events in Asia, where like the Shanghai Blockchain Week, like you could actually feel the energy and everyone's there. And it's just like so amazing to kind of like, most of the time you're interacting with people online, but to be able to sit down with them and actually have interesting conversations, like it's just a different level. I feel my mind goes to like Consensus, probably like 2016, when the original DAO was about to be launched, and there was sort of like a fear / excitement in the air that what's going to happen if this thing actually launches. And then, $150 million actually moved into the DAO contract. And it was our good friend reentrancy that played a role there as well. And the hacker was actually able to exploit that and drain the DAO. And I feel like living through some of those moments and actually seeing the reactions of people and the industry, like it's just it's not that like it's a good memory, but it's definitely an event that comes to mind as one of the more memorable things.
Absolutely. Tide moves very quickly in crypto, and that's a great example. All right, well, that's a wrap for this week. Thanks so much, Muneeb. If you enjoyed your time with us, please subscribe to the Stacks YouTube channel, where we're going to continue posting these sessions. And if you'd like to hear more about Stacks, head over to stacks.co and check out all the resources that are listed down below within the whole ecosystem. And we are going to be tuning back in next week, and we would love to continue to get questions from the audience. We'll share these on Twitter, and looking forward to hearing from the Stacks community. Thanks, everyone.
Awesome. Thank you.